for sure, for sure.
But I haven't even had a use case because most of the time you find there are other solutions that you can use instead of doing the reactive thing.
Oh yeah, I mean, especially I think if you could do like WebSockets, if you like want an open channel and do data transmission consistently on that open channel, you could work with WebSockets. So you have a few options of things you could use. So you don't necessarily need to deal with WebSockets. But regarding virtual threads, I think what they promise is if you find yourself spanning too many threads within your application, you can span the threads and not worry about overloading the CPU, because the threads that you can span are limited by the CPU you are running on top of, right?
True. It's a very good. I saw the technique. It's really ingenious.
Oh
yeah. That thing, the way the demon thread is just rocking on that platform thread, then being able to know when to release, then when to hook back. It's amazing.
Yeah, it's really good. It's really good. So I guess it can be good if your threads don't live for a long time. If you have short-term threads,
short-term thread.
Yeah, you span, you do something quickly, you release it. But if your application is a request comes in, you open a thread, and then that request takes like a few seconds to process, then you release that thread.
It's counterproductive.
Yeah, it might be tricky because you still want your application to be consistent to the hardware it's running on. So if I know I can only span 4 threads, which means I can process like 4 requests if each of them are taking like maybe a second to process, then I can hook them into 4 actual CPU threads, and I can optimize from there. Maybe look at ways to make my threads run faster, make my processes a bit quicker, reduce the workload or something like that. But just spanning additional threads, it wouldn't necessarily make the app faster. So that becomes
let's see what it holds in the future, for the writing libraries will be something to look at.
Oh yeah, for sure. Even the framework, we'll see what Spring does with it.
I think they already started something on that. I haven't checked it out. I think I saw a glimpse of that, but I haven't checked the docs.
Okay. I think I'll check it out. Spring framework, virtual threads. Welcome, someone. Octavian, I forgot to acknowledge you. Welcome, Octavian. So we are just waiting for guys to join so that we can start. We agreed to wait until 8:10, so I guess we're already beyond the waiting period. So we can go ahead and get started. Otherwise, thank you guys for joining. So last time where we left things was on the Rick and Morty API. So we were trying to replicate some of the API endpoints of the Rick and Morty public API. I'll just share my screen here so that we can look at it a bit better. So we set out, I think 3 weeks ago, we set out on a goal to replicate at least some of the functionality from this API. So the API achieves not a lot of things. You can just get characters, episodes, and seasons from it. And the APIs, I think they have it available on GraphQL, REST. I think those are the 2 protocols they support. So we decided to replicate the REST API. I think we got one endpoint to work end to end. Let me just go to the project. So the character API endpoint, I think we're able to get that to work end to end right from the controllers. So this is some of the endpoints that we worked on. David contributed a huge chunk of it. So this is the character API, which we call show character because of the character name is reserved. It's reserved under the Java language, so we couldn't use it. So we decided to call it show character. So we're able to write this from the API endpoints right down to the database level, as you can see with the repositories and the entities. So following this, we did a code review, and then after reviewing some of those code, I opened these issues, which to me I thought they were less complicated and somebody would pick them up to program. But I understand people are in holiday season, so it's even tricky to like get somebody to start writing code for that. So unfortunately, nobody really got in. Oh, well, let me not forget this thing. So I forgot this one time, and it ended up creating a major problem. Where somebody like just showed up and disrupted the call. But anyway, I'll leave the chat one open. So I was talking about the API that we were building, so the Rick and Morty API. So I opened these three issues, and I just wanted somebody to create a persistence layer for seasons and create a persistence layer for episodes and seasons. Which I guess, there's that thing they call the professor bias, where if somebody is teaching a course multiple times, they assume the students are not smart for grasping it that very first time they introduce them to the concept. So maybe a majority of guys that we had on the call in the previous sessions were not really doing Spring Boot or Spring Framework, or at least they were new to it. So I understand why we haven't gotten code contribution. And like I said, also we're in the holiday season, so I guess it makes sense. So my goal today is, the goal that I want us to have is, one, to finish the code review that we were doing last time, basically looking at the code that was contributed by David Masharia, who is with us. Discuss some of the concepts that David introduced into the Rick and Morty API code base, and then from that post-merge code review that we will do, maybe we can write some code for some of those issues. My idea is we can do one or two to help us recap some of the ideas that we discussed in the previous sessions, which I think will make this session a bit more, time gapped, so we won't end up trying to cover a lot of things. There's also something that David wanted to explain more regarding something to do with the REST controller advice. So when you get to the MVC point, where we'll be discussing TDD and doing TDD with on the API and the controller point, I think I'll tag in David so that he explains that concept to us. So the first thing I want us to go to the code. Last time we left it at the service layer, I believe. So maybe we'll move from the service layer and look at the controllers. And there's a lot of literature there that we need to cover. So yeah, so we have plenty to go through. So I believe I have David's code locally. But then you can follow along. You can just go to the GitHub repository. It's public. You can go to samuel.oldguard, and if you can clone the repository and then open this in IntelliJ or whichever code editor that is your favorite. So this section is what we'll be going through. Let me paste the link to the repository here. So you can just clone it, just in case you don't have it on your local. So you can just clone it so that if we go through some of those classes, you are with us. Yeah, so let me just arrange these. I don't have to scroll as much. Yeah, so we went layer by layer. We started with the repositories. We looked at of course, we started with the entities, which we have one. We discussed that. We went to the repository, which, this is where we form our queries. So we discussed a bit of that. But if you're feeling a bit in the weeds about me talking about how we discussed that, all of those sessions are archived on our YouTube channel. So if you feel like maybe you missed some of those sessions and you'd like to go back and look at what we discussed regarding those repository layer, the persistence layer, and the service layer, and some of the concepts we discussed, you can just go to the video. So the video is referenced under okay. just go and share the link. View channel. So I've put it under podcasts. So under these podcasts, so far we've done I think 6 episodes. This was a fluke. So the one I'm talking about is under episode 7, which I split into 2 parts. So there's this part 1, and then there should be here's the part 2. So this comprises the previous session. So I think I can link the whole playlist. But anyway, if you just go and search for Old Garden, then look for that podcast playlist, you guys can find it. So at your free time, you can look at some of the concepts that we discussed in the previous sessions. And we'll be doing that for every session, so that if you miss out, you don't miss out completely. You can always recap. Also, if you miss out, if something doesn't make sense during the session, you can just go back to it and reference it. Okay, so let's proceed. So I was saying we discussed the entities, we discussed the repository layer, and we discussed some concepts in the service layer. How these are plugged in with the application properties file, and David explained the idea and the design behind some of these algorithms that he came up with. So today I want us to move forward. Of course, we also discussed AOP and in the context of exemption handling. So we discussed this global exemption handler, and all of that is available in those previous episodes. So today I wanted us to go to the controller level and just talk about the APIs and not just the APIs, but also how you test those API endpoints. So for the show character, from the existing API documentation, as you guys can see, so this is the API endpoint. So in our case, we had something different, but I guess the main access, what we call the web context or sublet context for us would be, I'll just replace this with that. So if you go to rickandmortyapi.com, and let's imagine we are this is the main code base for it, and then you go to /API URI. So API URI is /API/v1, which you'll see it's kind of the same, only that we added versioning for the APIs. So you go to rickandmortyapi.com and then /API /v1 and then /character. It will lead you to this endpoint. And I think that brings the first question about how you design REST APIs. Maybe I can talk a bit about that before we go to testing the REST APIs. So REST API is not limited to the framework that we're using for this particular exploration, if I can call it that. So REST is a protocol that's used for a lot of web services on the internet, and within the protocol they define how you structure your API endpoints. So one of the things is you set up request URIs. So URIs, of course, I allow you to define how particular resources on your server can be accessed. So in this case, we have, if you look at, for instance, from the documentation, so we have character, location, and episodes. So you can think of this as the resources that you're trying to access from that API, and this /API/character is the URI. Basically, it's pointing to where we can find that resource. So most web services are built for you to access that. So other machines can access resources on your server, and other clients can access resources on your server. And the clients can be a browser, it can be a mobile application. You can have multiple clients. Some people even get as creative as having a Raspberry Pi as the API client. So it will be hitting your server for those resources. So we follow the same standard in Spring. So to define your REST API, one of the things you need to have is this REST controller annotation. And just like we discussed last time, Spring uses these stereotype, they are called stereotype annotations, to allow you to mark particular sections of your whole API. So for instance, you can say, this is my persistence layer, this is my service layer, this is my controller layer, the API endpoint definition layer, and within those you can use annotations to kind of specify that that particular layer is handling this particular function. So if you look at the code base, you'll see within the repository layer we have at repository, so that marks this as the repository layer. Within the service layer we have at service, and then of course in the controllers you'll see we have REST controller. So you can use general controller. There's a general controller annotation, this one, and this is used to mark general controllers that are not necessarily REST controllers. Most developers, and personally what I use that general controller for is if I have a server rendered page, an SRP, which is like an admin, maybe you have like an admin web page that you are hosting for the service, and this could be used by the platform owners to do things like back office related things, or if it's just for collecting analytics and stuff like that. So you can define those with that controller, because those are not REST, they are not REST API endpoints. But if you are specifically defining a REST API, then you use the the specialized annotation, which in this case would be a REST controller. So if you look at the docs, I think it should indicate the same thing. So this is the Java doc for the REST controller, and it says it's a convenience annotation that itself annotated with at controller. So it also inherits from controller, the one I just showed, and the response body. Types that carry this annotation are treated as controllers, where request mapping methods assume response body semantics by default. So what this means is, usually when you define a REST API, you expect to consume particular types of, or other formats of data. So you're either processing XML or JSON. If you're doing something like GraphQL, which is a standard on its own, then maybe you'll be consuming protobuf. But for REST APIs, you're either dealing with XML or JSON. So you'll be receiving XML and feeding out XML as a response, or you're receiving JSON and feeding out JSON as a response. So when you mark a class with that annotation, then the framework is able to actually determine that particular layer will be used for that purpose, for receiving data from the internet and processing it in a particular standard, and then returning the same data in a particular format. Yeah, so that's the purpose of the controller. Yeah, David, you can go ahead. Let me just briefly turn this on. Yes, David.
Oh yeah, I just saw you explain the difference between the controller and the REST controller, and I thought I also add something. So the REST controller part comes in when we have mainly we are dealing with an API endpoint, and also something to maybe for someone to remember easily. When you have a REST controller, the response must be either maybe a JSON.
David, we lost you for a minute there. David, can you hear me? I think we lost David. But if he comes back, I'll allow him to finish his explanation. So as we wait for David to get back his connection, I think I'll just go through the chats here. I think there's some interesting comments. David, if you're back, you can just...
Oh yeah, I just wanted to make it easy for people to remember the difference between REST controller and the controller. So for the REST controller, there is a response body involved. And for the controller, it's returning a string that can be resolved into a view, especially when you are fetching HTML directly from an endpoint, just like you're explaining about the admin thing.
Oh yeah, for sure. So Um, oh yeah, exactly, and that's why I mentioned the SRP case. So if you're building like an admin, a single page admin web page thing that you want to run on the server to help with analytics or to provide a back office for the product owners, so you can use that controller. And within Spring Framework, we have things that are called view resolvers. So, and the way the view resolvers work, you just return a string, and the name of the string will be matched to the name of a HTML template that you have within your code. So maybe you have admin.html, you can just return admin from that controller function, and then it will pull out the admin.html. And it would look something like this, just for the sake of demonstrating. So let's say we have a directory of web page. Let me just say page, web, and within web, maybe we have admin page, controller. So within here, instead of marking this with the rest controller, we can just mark it with controller, and then we can have a function. Of course, we still give it mapping. I'll explain what these are. And we just return a plain string, and then maybe you call this index. So then you just say return admin. So just this simple string can identify, just on our templates here, can end up identifying something like admin.html. And that admin.html is actually a HTML web page. So by having this, when somebody hits, let's say from the root resource, maybe they hit slash admin, it will load up this admin.html, and that becomes useful. I think, David, that's what you were explaining. If I manage to put it in code.
Yes, exactly.
Wonderful. So you notice the difference between this and our usual controller. You notice the usual controller actually has a response entity, and it has a request body. So response entity is a bit more detailed HTTP response, because now you're dealing with an API. So a response entity can have status codes, it can have the body of the data that you're returning, which, like I said, could be XML or JSON. So there's a bit more information there. Before I proceed, I'm seeing we have some comments, so I'll just go ahead and read some of them. So Isa is saying Spring Boot looks a bit like Nest.js. Interesting. Yeah, I don't think that's good news for the JS crowd because JavaScript is a browser technology, or at least it should be a browser technology. Right? Nowadays, some people are using it as a server-side technology. So I don't know if that's good news. But if somebody is doing Nest.js, at least when they pick up Spring Boot, it will be like easy to work with. But also with these web frameworks, where what you guys can end up noticing is the web standards are already written. HTTP is a global standard that's used by any machine on the internet. So most web frameworks actually look the same. So if you take Spring Boot and Laravel and maybe Node.js, you'll find that the differences are very minimal. They're more philosophical than technical, because the technical details have already been defined in the RFC specifications that are out there. So the frameworks are merely implementing what the World Wide Web RFC specs have already talked about: how you do HTTP1, HTTP2, how you do security of the web, how you do everything that entails communications on the internet. So these frameworks will actually end up looking kind of the same. Octavian is saying, yep, similar concept, e.g. annotation, Spring Boot, and decorators Nest.js. Yeah. I can imagine even the code syntax might end up looking somewhat similar. I think the framework that I haven't seen use of annotations, especially the stereotype annotations that I have shown there, are within Laravel. I didn't see that in Laravel. I don't know if there's a way in Laravel for you to dictate layers of your application, like we've seen where we've specified this is the repository layer, this is the service layer, this is the controller, like the API endpoint definition layer. I don't know if there's something like that. Lennox, if you don't mind, is there a way to like specify that this PHP file is handling is actually a controller, or this PHP file is a repository holder, or this PHP file is an entity?
Not like out of the framework that I know, but there was this a new package that was called Lucid Architecture, and they were trying to address such things. But I've seen other projects that do the same, like you just say like this is a repository, this is a controller, this is a domain. You can do that, but like it is not written in the framework itself.
Okay. Oh yeah. So I think that might end up being the unique thing. But even if you are doing Laravel, you'll still end up writing controllers. You'll still end up writing PHP repository files. They might even end up being classes, because PHP now has OOP, and you might have entities. It's similar concepts all through, which is nice because it allows backend developers to once you know one framework, you can switch back and forth as long as you understand the language. So Lennox is saying, I thought they were the same until I googled. They are not the same. I think he was referring to Nest.js and Spring Boot. A decorator corresponds to a function that is called on the class, whereas annotations are only metadata set on the class using the reflect metadata library. Within Spring, the annotations act as metadata, and the Spring application context, the runtime where Spring is operating, is able to pick up those annotations and apply particular behavior to places where it finds annotations. So if you add a repository annotation, Spring will plug in if it's a JPA repository, it will plug in the CRUD methods. So create, read, update, delete. So you'll find all, delete all, delete by, find by. Those query methods are already plugged in for you by virtue of having that repository annotation. The same thing with the entity. Once you define it as an entity, the Spring will push that down to the respective ORM, in this case Hibernate, and try to create a database table for you. So it's metadata, but it triggers behavior. With TypeScript and ES7, something is a decorator. In the context of Angular, decorators like component, injectable, define metadata for the decorator element using the reflect define metadata method. So I think in this case also it's used as metadata. Okay, so you plugged in a Stack Overflow question here. So let me just bite. Let me see what this entails. What is the difference between annotation and decorator? So I think this is in the context of Angular. A decorator corresponds to a function that is called on the class, whereas annotation are only metadata. With TypeScript, okay. I think kind of the same text that you shared. I've seen there.
No, even the reason why I Googled for that is because we had something like decorators in, was it Fast API? Either Fast API or class. Those two, they are like a decorator. You could write your own decorator if you wanted to authenticate someone. And annotation is something I'm hearing now, and there's also a Java dev that I asked a couple of months ago, and they told me that it was a decorator, and it was an annotation, and then me on the other side I'm saying it's a decorator, and we argued. Because for me, my source of truth was Python, and on the side it was it was Java. And today is when I had to ask and see the difference.
Yeah, and also seeing it in practice, I think demonstrates the difference a bit better. So Linux is also saying, so there's Nest and Next. There's a new JavaScript framework. I think after we finish this session, there'll be 2 new JavaScript frameworks that are released. So they might end up having name collisions. But there's Nest.js and Next.js. Next.js really came up like it was going to replace things, and then I don't know. We had this other one that came out. That's some interesting name, like the name that corresponds to like a dough, like if you're baking. I don't know. It had some interesting name. Also, that seemed like it was going to be the one, but it's always the case with JavaScript.
They know what I don't need.
Sorry, I think it's close to that. What did you say?
Then I don't even know how to pronounce it. Then JS.
Yeah, something like
And
that.
then came ban.
Oh yeah.
But
But interesting thing is they always come to replace something, and that's the problem I have with JavaScript developers. Like instead of addressing a problem in a package, you try and create a package that addresses like more of like a political thing. See, why not just go there and fix the problem yourself? And now, like I think it was just Node.js. They had a problem with it. Now came ban. It came Node.js. Then Deno has a problem. Now we have ban. Then also like there also like LV kit and all those. Like there's always a framework that addresses a specific issue instead of now just choose one and like let's make it better. And I think even the folks from Java and even Python, not Python really, no, PHP are really doing a credible job at that. Like if there's a problem with a package, they address that problem in that same package.
Yeah, I mean that really helps. David, before I weigh in, maybe David, you wanted to say something?
No. I was just agreeing with Lennox about I saw ban was supposed to replace Node.js. Then I don't know what happened with that. So yeah, I was just agreeing with him.
Oh yeah, I mean it's unfortunate. What I like about what we have in the Java ecosystem is we have like a hierarchy that helps in when problems emerge within the framework or new technologies are introduced. You don't see a new framework coming up, and I think the structure that's available in Java that allows us to do this is we have everything starts from a specification. So somebody doesn't just write up a framework and release it. Everything starts from a spec. So, and there's a project that handles that spec. In the previous sessions, I referred to it, the Jakarta, when it comes to web development things. So you have the Jakarta project. And the Jakarta project, their job is to push out specifications based on evolutions on the internet. And when that specification becomes available, we get a reference project. So, for instance, with REST, there is a project called JAX-RS. And that JAX-RS is a reference implementation of the REST protocol for us. So then you don't need to have like frameworks mushrooming every time something changes on the internet. And I think that has allowed us, because in a way, all the frameworks that are available in Java are serving a unique need. So Jakarta serves the specification bit. Projects like JAX-RS serve the reference project need, like Aspect.js, Aspect.j, the one we looked at last time, is serving a specific need, which is being a reference project for aspect-oriented programming. And then now we have the full-on framework that takes the reference projects and then plugs them into one house. So you'll see Spring is following what JAX-RS is doing, but actually having JAX-RS as a dependency to the project. JUnit is handling unit testing, and Spring has JUnit as a dependency to the Spring framework project. And then for us, we consume Spring framework. So we get the spec, we get the reference projects, and we get the implementation of those reference projects, rather access to those reference projects in like a larger context. So when an ecosystem is functioning like that, where everybody is working towards the same goal, then it helps in evolution and reduces knocking of heads and quarrels. Not to dwell on this too much, but I remember when React came out, it caused an uproar. People were really angry about it because it took the standards that were already there and flipped them upside down. And of course, being pushed by a major company like Facebook, it still ended up getting adoption, although like the first impressions, guys were like, this is the wrong way to go. But it's unfortunate. I hope people in the JS ecosystem will one day sit down and just agree on like a way to govern their evolution, so that we don't have this is like 1,000 frameworks. Because like today, if you want to start a web project. You know, it's really difficult, and the stress is: do I go with Angular? Do I do Vue? Do I do Next? Do I do Next? Do I do what? You know, there's just like 1,000 options, and they're not unique. All of them are kind of providing the same need, which is building something that runs on the browser. Yeah, but you know, let's hope that things will change. Oh yeah, for sure, they agree in private. The creator of JavaScript came out and decided that we communicated to the framework, to the community, that they needed a real language. So I don't know, maybe you might spear ahead some approach that will, you know, maybe restructure the community. But yeah, it's chaotic. Yeah. So not to dwell on that, let's go back to the main agenda for the call. But I appreciate that the discussion there. So we're looking at. So as I speak, let me just disable these controls. Guys who attended the previous sessions understand why I am very strict on like those controls, because they can lead to instant chaos. So let's just proceed to where we were. So I was talking about the controllers. I think now it's good we understand the difference between the two controllers. So the REST controller allows you to process, to receive and serve either XML or JSON. And then the general controller, which is like not the REST controller, it allows you to serve plain strings. And those plain strings are, like I said, are used in the context of building a web page. So just return the name of the template file, which in this case is a HTML file, and this will be loaded for you at runtime. So let's just go back to the controller. So another annotation that is commonly used in these controllers is the request mapping annotation. So request mapping annotation allows you to define the URIs. So the request URI. So like in the Rick and Morty API, you have /API/location /API/episode. So those URIs are defined under the request mapping annotation. So when you do request mapping at the top of your class, you're actually dictating that every endpoint that can be processed by this class, its origin URI is /that. And that allows you to split your API into the resources that they serve. So, for instance, this one, the request mapping is pointing to character, which means that this endpoint handles everything regarding the character. So if you imagine this as a CRUD endpoint, where we are creating a character, we are fetching characters, or we are fetching character by a particular filter, all the specialized needs for accessing that API will be within that class. Let me demonstrate what I mean by that. So the other resource that we have in the documentation is location. So if we created a location controller here, location controller, and of course we add the REST controller annotation. So marking this as a controller, and then when we add the request mapping annotation, we can specialize this to, so David added this utilities class that has the root URI, which is /API/v1. So you can have that, but then the next thing that we have there is location. So then, if you look at these two controllers side by side, you'll notice this controller handles character, this controller handles location. So for instance, from the documentation, this will be this and this will be that. So you can have other endpoints that mushroom from location, maybe location /user/id, and location /user/id will have to be within this class. So you can have maybe a get mapping for it, and maybe say public response entity. For this demonstration, I'll just use string. Let's say we are returning a JSON string, or JSON that contains one string, and get user location. Just for the purpose of this demonstration, let's just entertain the idea that we are doing that. So now from location, we can go ahead and say slash. So we don't need to repeat location, slash user, slash, so maybe the user ID is a path, the path variable. So that allows us to have now specialized endpoints under location. So the same with character, you'd see we have specialized method like slash create, slash edit, slash find by name, slash IDs, where you pass in the IDs and you're able to pull them. So now we can have specialized methods for the root resource URI. So that's how you define your root resource URI. So apart from REST controller, there's another notation that David used here, but this is not REST API related. This is actually so this is actually from Project Lombok. When we were doing entities back then, you noticed we had this all argument, no argument, getter, setter to string. I don't know if I should go back to that story, but one of the things that Java receives hate for is that the language is verbose. So a lot of people believe the language is verbose because you have to, when you're creating a simple model, you have to create those getters, setters, to string hash code methods. So there's a project that emerged in the ecosystem, and it aimed at addressing that issue. It's called Project Lombok. And what it did, instead of having those getter setter methods, like in this case, maybe you'd have get ID, maybe you have set ID. Instead of that, we would just have annotation. So this getter would handle all the get ID, get methods that we need, get ID, get name, get description. And then the set method would handle all the set function that we need, set ID, set name, set description. So anyway, I already covered that. I just needed to do a recap. So one annotation that David utilized for this was this required args constructor, and the required args constructor basically plugs in a constructor into this class. David, do you want to talk about it? Maybe I'm not doing it justice, and maybe explain your motivations for using it. You can go ahead, David.
Oh. No, you are explaining it pretty well. Only that I wanted to say that when you use the required args constructor, it will just create a constructor with every field that has been marked final. So all the other fields that have not been marked final, it won't put them in the constructor.
Oh yeah. Thank you for that explanation. So if you have final fields, those will be plugged into the constructor. And I think the reason for that, although we discussed this last time, is we talked about the Spring, something called a factory pin. So within Spring, there is a concept of IOC, inversion of control. It's basically dependency injection if you're coming from a different framework. So within Spring, we have like a container that's defined to hold objects, and you can use these annotations to inject those objects into the places where you want to use them. So one of the annotations we looked at was auto-wired and the other ones. So the way you plug in singleton objects within your the components of your program, so you can use two approaches. One is constructor-based injection. The other one is annotation based injection, where you use the auto-wired annotation. So you'll see its use in some places. I think we used it maybe in the service layer. Okay, David didn't use any auto-wired there. So because he's using the required args constructor. So maybe to demonstrate. So we have this final object, character management service. You'll notice that character management service is actually marked with one of those stereotype annotations. So in this case, at service, which means it's managed by the Spring IOC container. So when we need it, we can request it from the Spring IOC container, and Spring will be able to give us an instance of character management service. So for that, we don't need to do new character. We don't need to do new character management service every time we need a character management service. You can just inject it. So guys familiar with dependency injection, I'm preaching to the choir here. So one of the ways is through constructor injection, which is actually what's happening here. But let me just demonstrate how this code would look if we didn't use that annotation. So we would have that, and then we would plug in a constructor. So show character controller, and then we would have a character management service, and let me call it management service, and then within here we would say this dot character management service is equals to management service. So through this constructor, the Spring IOC container would be able to inject the character management service, because the way the IOC container works is for all these objects that we've used the stereotype annotation, whether controller, REST controller, service, repository, the Spring IOC container maintains a single instance of them. And they are referred to as beans when they're in the IOC container. And anytime you need to use them, the Spring is able to inject them into the part of the program where you want to use them. And in this case, it will be through the constructor injection. So when it's initializing show character controller, which is also managing, it will be able to plug this in. So this is a constructor injection. So the other approach would be using annotations. So if we didn't do that, then we would use @autowired, and this would serve the same purpose. So you would be able to maintain an instance of character management service. So those are ways how with which we plug in things, and you can look at this as just doing @inject. Actually, I believe it inherits the framework @inject. If you're working with maybe things within mobile, Android, I know that uses that @inject annotation. Maybe some other frameworks also use the same approach, but autowired is just like @inject. So let me just get this back to the way it was. So now, if you see that required Ags constructor, it will inject the character management service through constructor injection. It's only that now you don't need to write up the constructor. Yeah, David, you can go ahead. You can go ahead, David.
Sam, I wanted to add something since we are trying to learn. Spring highly encourages us to use constructor injection whenever we are playing dependency injection. And the reason is because they point out that whenever you use constructor injection, the singleton formed is kind of, it's safe. It's grade safe since it's immutable, since everything is being instantiated at the first place, compared to other sources of injection like Zeta, where something can be changed after instantiation, or also the field constructor, field injection. So that's something to look up to whenever you're doing whenever you're doing injection, try to always do it in a constructor.
Yeah, I honestly didn't know that. So the constructor offers more thread safety, right?
First, more thread safety, since whenever you are passing your object during the first initialization, already Spring knows this is what you're gonna use, and it won't change whenever after instantiation. Also, it marks the being created. You'll have all the dependencies ready, so you won't run into trouble of what we call the circular dependencies and stuff. It's more stable doing it that way.
Oh yeah, I think especially on the circular dependency. But I honestly didn't know there was that much of a difference between using field injection and constructor injection. I only know that a lot of. Sorry, you're saying something?
Oh yeah. They encourage you to do the constructor injection. Among the 3 types of injections, do the constructor one. That's what they encourage you to do.
Oh yeah, because I know some Java developers are zealots when it comes to annotations, so they really don't like using annotations within code because they believe it kind of dirtifies the code. You're not using plain language.
True. It also comes with the extra runtime activities that you don't need, of which whenever you have a choice, you could have done it the native way.
Oh yeah, for sure, because it has to process the metadata again, right?
Yes.
Yeah, so thank you for that input, David. Yeah, so that makes sense. So I see why your code, I see why your code doesn't have the art auto wired. I looked at it, I looked for it, and
I try to avoid it whenever I can.
okay, okay, thank you for that. Let me just disable this. Oh yeah, so maybe I can read. So Wesley saying Ruby and Rails dev, but I'm loving what I'm seeing. Yeah, I mean, web development is like I was saying earlier, it's standardized. So whatever we're discussing here, in some way or another, it will reference what you're working with. But of course, there'll definitely be some specialized use cases and ways of approaching problems that we might have here. But anyway, thanks Wesley. Yeah, so I added this for demonstration purposes, but I think I can just clear it out. I think we've gotten the idea. Yeah, so I think so we've looked at some of the basics of kind of setting up the endpoint. So now we'll go to where we have the endpoints themselves. So we are plugging in the character management service in this case because we'll be using it to process some of the requests. I think all the requests are using that character management service, so that's why we need it here. And the fact that it's a managed, let me call it a managed class within IOC, although the right term is bean, because it's a managed class within Spring, we're able to inject it into the controller and use it for processing. Okay, so now when it comes to the endpoints, so this takes us back to HTTP methods. So within HTTP, you guys know we have a few supported methods. You can have get, you can have put, post, delete, and a few others. So Spring provides an annotation for all of those HTTP methods, and what you can do is you can mark your functions with those with an annotation that matches the HTTP method, and the Spring will be able to enable it to process the specified type of request. So anything that is a post mapping, you'll notice we're using the post mapping annotation, and that will convert this into a post endpoint. So it can receive form data, it can receive JSON data, and you'll see that we have this request body, which means the request that's coming in has a payload. It has some data that's coming with the HTTP request. So when you mark it as a post mapping, it means this is a post endpoint, and it can process such requests. So things like indimpotent, I hope I can pronounce that correctly. Things like indimpotent processing, like post method. So let's say somebody is submitting a form on a browser to that post endpoint, and some of those browsers have this inbuilt function of like when you submit the form twice, it can like ask you, are you sure you want to resubmit this data? Because it knows that's like a quote dangerous operation. So some of those independent functions will be available for you by when you mark the functions with that post mapping. Of course, the others, like this will become a put endpoint, and this will become a get endpoint. So basically able to get all that's available. So the others that we are not using here, like delete mapping, so get, post, put, delete. There are some specialized ones that I don't know whether Spring provides. You can use okay, let's just focus on the main ones. But anyway, you have post, put, get, and delete. But there's trace and then there's head, which from the servlet specification, I can actually define them as endpoints. But I don't know if Spring supports them. It might support trace. Let me just experiment. No, it doesn't support trace. So I think it just supports the main HTTP methods. But if you are writing your own servlet, I think there's a way you can like program it to handle some of those other methods. Okay, so anything you need will be available for like stereotype annotations. So these annotations receive arguments. The main arguments is the request URI. So this will go to character/create. So that's the endpoint. This one should go to character/edit, and then you're able to pass in an ID. Without going into too much detail, maybe I can just talk about a few things. So from the post mapping annotation, I think we can see that we have the post mapping, which I've explained, that marks this method to process post requests that go to that URI. The other thing in the function arguments, we have this request body annotation. So the request body annotation defines the data that we are receiving to process the data. You'll notice with the put mapping, so put mapping can also receive a payload. So you'll see it has the request body annotation, and the get mapping it doesn't have a request body. Although in some cases, I think you can plug in the data that you want to pass in through maybe a path variable or a request param. Maybe the other thing here is the response entity. So this allows you to define the nature of the response that you're sending back. By default, the response you're sending back on Spring is JSON, but there's a way you can specify it to return XML. But the default response type is response payload format is JSON. Even the request data that can be processed is JSON. There's an annotation that you can plug in to define this as receiving XML. It's usually plugged in as part of the arguments for the body. So you'll see within the annotation specification, there's this consumes and produces functions. So with this consumes and produces variables of the annotation, you can actually specify that you want to process maybe text data or XML data or JSON data. And I think the way it works is you can say consumes equals media type dot. So there's a few types of media type you can process here. Oh, okay. I didn't know they added GraphQL. Anyway, there's GraphQL there. But anyway, there's application atom XML, and I think this should be familiar if you've ever written like a web endpoint. There is form URL encoded value, so this is very common. So if you're doing a HTML form, you'll likely be processing that. So you can specify that, and now this endpoint will be able to receive URL encoded form data. Of course, there's JSON value, which we're using by default, and that will check the request header for type application/JSON. So the client, while sending the data, of course, in the header they'll specify the format of the data they're sending, and that will be able to process application/JSON. So if somebody sends maybe applications, this one, URL encoded value, application-xw dash form, and that, if the endpoint is designed to process JSON data, when somebody sends URL encoded form data, it won't be able to process it. So I think you get like a 500 you get a 400 bad request when somebody tries to do that. But by default, you're processing JSON. There's a few other data formats here, but of course the most common ones are XML and JSON. So I'm seeing even protobuf. I think this would be used if it's a GraphQL endpoint. RSS, XHTML. This is the main one for processing XML, application-XML. So this will allow you to receive XML data. So you can experiment with some of this. Multi-part form data, this would be if maybe you want to upload a file to the endpoint. Most engineers will use the multi-part form data type to do that. So that's also available for you. So you can actually change the annotation to define what you want to process. So we look at what you're receiving from the client. So you can also specify the format of the data you're sending back to the client, and you can do that with producers, and also you can use the same media type class. And media type, you could kind of have access to the same methods. So if, for instance, you are returning, let's say, application XML, you can just annotate